Hello everyone, this is lesson 8.4, properties of rhombuses, rectangles, and squares. So in this lesson you're going to learn all the properties of these three different types of quadrilaterals. So we're going to start off with a rhombus. So a rhombus is a parallelogram, which means that all four sides are both opposite sides are parallel, with also four congruent sides. Okay, so it's a special case of a parallelogram where all four sides are congruent. So because it's a parallelogram, we also know that both pairs of opposite sides are congruent. So both pairs of opposite sides are congruent. So I'm basically listing the properties of the parallelogram that we went over on Friday. Both pairs of opposite angles are congruent. So both pairs of, I'm doing little quotes, which means just repeating, both pairs of opposite angles are congruent. Both pairs of opposite sides are parallel. Diagonals bisect each other. And then one pair of opposite sides are congruent and parallel. Are congruent and parallel. So there's other special properties of the rhombus. So because it's a special parallelogram, it also has the diagonals are perpendicular. And diagonals are angle bisectors. This is not always true with the regular parallelogram. Diagonals are angle bisectors. Okay, so what that means, let's go ahead and take this rhombus here. Let's draw in the diagonals. So there's BD and AC. So the diagonals are perpendicular, so we can draw a little perpendicular symbol here. And they're also angle bisectors. So here, this diagonal splits angle D up into two congruent parts. And then since opposite side angles are congruent, then they're also going to be the same angles on the other side. And then we can draw two arcs for these. All right. So here's some practice. So let's go ahead and draw the diagonals. So draw a rhombus, and then draw the diagonals. So they said, let's see, it's PQRS. So let's do PQRS with intersection point at T. So they're saying that ST is 13. So if ST is 13, find SQ. Well, that would be the whole thing. So that would be twice that, so 26. If the measure of angle PRS, this angle here is 17. What's the measure of angle QRS? Well, it's going to be twice that, so 34 degrees. Find the measure of angle STR. STR, that's this angle, which would be 90. And then PT. All right, so PT is the same as TR because of the property of bisecting. And we also know that this here, this angle measure is 17. And we also know that this segment here was 13. So we can actually use one of the trig functions to figure out TR. If we look at this as a right triangle, and this is our hypotenuse, we know the opposite side, and we're looking for the adjacent side, so we would use the tangent. So the tangent of 17 equals opposite is 13 over adjacent is what we're trying to find. So here we could put this over 1, cross multiply, and we would get x times the tangent of 17 equals 13. Divide by the tangent of 17. And if I plug that into my calculator, 13 divided by the tangent of 17, I get 42.5. That seems like it's really off. Let me make sure my calculator's mode is in degrees. It is. So I get an answer that's pretty big, 42.5. But that would make sense because this is definitely not drawn to scale if this is 17. This is probably going to be more like squished down if this is 17 and this is 17 degrees. That's a pretty small angle rather than what it looks like, which is 45. So it does make sense if the opposite side is so short that the adjacent side would be longer. All right, and then if SP is 4x minus 3, so SP is this side here, and PQ is 18 plus x. Well, all four sides are congruent, so we would just set these two equal to each other. So 4x minus 3 equals 18 plus x. Move your terms over, 3x 21, x equals 7. All right. The next step in parallelogram is the rectangle. So a rectangle is a parallelogram with the special property here would be 4 right angles. 4 right angles. So here you have a rectangle, opposite sides are parallel, and the right angles are shown. So because it's parallelogram, we know, and then we don't have to say everything over again. I'm just gonna do like repeats here. So basically everything we said here. So both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. Both pairs of opposite sides are parallel. Diagonals bisect each other. One pair of opposite sides are congruent and parallel. So all the same properties as the parallelogram, but you've also got the one special property of the diagonals. The diagonals in a rectangle are congruent. Diagonals are congruent. And remember, this is the first time that this has happened, that the diagonals are congruent. They're not always going to be congruent in just a general parallelogram. And they're not congruent in a rhombus, only if the rhombus is a square. Now note, though, that the diagonals are not going to necessarily be perpendicular or angle bisectors anymore, but they are going to be congruent, and they're still going to be bisectors of each other. So let's do a little practice with this one here. So I'm going to draw in my diagonals. Oh, wow, I meant to put, what happened to my line tool? Let's try that again. There we go. Okay, E, F, G, H. So let's do E, F, G, H. Diagonal intersection point is D. So they're saying angle H, F, G, this angle right here, is 48. Okay, and we also have to sacrifice our right angles. So we don't have right angles anymore, but you do have like these right angles here. Like, do you see those? Because to make the right angle. And then EG is 18. So this whole part right here, which would be the hypotenuse of either of these right triangles, that would be 18. So EF. So EF, we're looking for this side right here. Okay, so if we know, well, this is going to be a little bit tricky. So we know this here is 18. That would be our hypotenuse. Let's see, we do know some things about the alternate interior angles. So let's play with some angles here. So this would be 18. Sorry, not 18, 48. And then this here would be 90. So, or the whole thing would be 90. So this would be 42. And then this is also going to be 42. Okay, so if that's 42, then, let's see here. Okay, maybe let's consider the fact that if this whole thing is 18, then this is 9.